Hello all, thanks for taking the time and joining this presentation. I am Manish Kapur, Senior Director of Product and Solutions at Sonar. Today I am excited to talk about building reliable software in the age of AI. We are witnessing how AI and LLMs are redefining the software development workflows. I will be sharing how Sonar's AI Code Assurance and AI CodeFix can help you adopt AI coding confidently. Let's dive in. Here's the agenda for this presentation. First, we'll explore the benefits and challenges of AI coding, with a focus on understanding LLM hallucinations, a fascinating but problematic aspect of AI-generated content. Then I'll introduce you to Sonar and our AI Code Assurance solution, which helps build trust in AI-generated code. We'll also look at AI CodeFix for automatically fixing coding problems. Finally, I'll end with some key takeaways and resources for you. Let's get started. AI is rapidly changing every stage of the software development lifecycle. Looking at where we are today, as shown on the left-hand side, we see AI-assisted processes becoming mainstream. In the design phase, we have authoring assistance tools helping developers write better applications and specifications. During coding, we have coding assistants like GitHub Copilot, Amazon Q Developer, Codium that are helping developers code faster. For testing, AI is generating test cases automatically. Even in release management, AI is helping with scheduling deployments. But this is just the beginning. The future, as shown on the right-hand side, points towards AI-generated processes, from spec to code translation that creates implementation directly from your requirements, to AI agents for coding that can handle entire coding tasks autonomously, to self-healing code that fixes itself, and AI-generated release plans that can optimize deployment strategies. The question isn't if AI will transform software development, but how quickly and thoroughly it will do so. The benefits of AI coding tools are compelling and are proven by their rapid adoption. First, there's a significant boost in developer productivity and happiness. Developers can write code faster with AI handling boilerplate and routine tasks. Auto generation and auto completion features reduce the cognitive load, allowing developers to focus on more creative aspects of coding and problem solving. Second, these tools accelerate time to market. By expediting the software development lifecycle and automating routine tasks, teams can deliver features and products more quickly, giving businesses a competitive edge. Perhaps most importantly, AI is democratizing coding with new ways like vibe coding, which is being discussed in the industry these days. It's making software development more accessible to people with varying levels of experience and expertise. Junior developers can leverage AI to learn and contribute more quickly. This broadening of who can participate in software creation is perhaps the most transformative long-term benefit. Despite these benefits, organizations face significant challenges when adopting AI coding tools. Let's address the essential challenges that we are seeing. Teams can often discover that AI-generated code can be buggy or can contain security vulnerabilities. There's the issue of hallucinations, where AI confidently presents incorrect information as facts, which we'll explore a little bit more in a moment. There are also process concerns. Who is reviewing all the AI-generated code? And engineering managers or leaders have their concerns too. Is the AI potentially exposing our intellectual property? Are we inadvertently introducing security risks? And when something goes wrong with AI-generated code, who's accountable? Finally, there's the bottom line question that leadership always asks. Show me the return of investment. These challenges require thoughtful approaches and robust solutions to address effectively. Let's focus on hallucinations. One of the most significant challenges with AI-generated code. What exactly are AI hallucinations? They are AI-generated content that seems plausible but is actually incorrect. They occur due to limitations in training data, context boundaries that AI cannot see beyond, and pattern overfitting, where AI applies patterns inappropriately. The real-world consequences can be severe. Production outages when hallucinated code fails, security breaches from imagined but flawed security implementations, and maintenance nightmares as teams try to understand the code that references non-existing components. In code specifically, hallucinations manifest as syntax errors, logic bugs like one-off errors, security vulnerabilities such as SQL injection, and references to APIs or libraries that simply don't exist. Understanding hallucinations are an inherent limitation of current AI systems is crucial. This is crucial so that you can develop strategies to mitigate their impact. Let's examine how more specifically hallucinations can impact code quality and code security. Syntax errors, while relatively rare with the state-of-art LLMs, can still occur, especially in edge cases or less common programming languages. More concerning are logic bugs, off-by-one errors, incorrect conditionals, and edge case mishandling that may not be immediately apparent but can cause subtle and difficult to diagnose issues in production. Security vulnerabilities are perhaps the most serious concern. AI systems might generate code vulnerable to SQL injection, cross-site scripting, or insecure deserialization without any indication that there's a problem. Code smells like duplicated code, poor modularization, and architectural violations can also accumulate, making maintenance increasingly difficult over time. And finally, the problem of non-existent APIs, where AI confidently references libraries, methods, or classes that actually don't exist in your code base or even in the real world. These issues highlight why verification of AI-generated code is not optional, it's essential. I recently came across this tweet from Aman, who is the founder of Cursor AI IDE, which is a very popular IDE among developers. In this post, he said, Cursor writes about 1 billion lines of code daily. To put that in perspective, the entire world produces just a few billion lines of code a day. What this means is that the speed at which AI is producing code is mind-boggling, and we know LLMs can hallucinate. This makes this makes code review ever so important. This also brings us to an issue which I'm calling accountability crisis. When issues are introduced by AI-generated code, who is responsible? The developer who accepted the suggestion, or the LLM vendor, or the organization that deployed that code? This question isn't just philosophical. It has real implications for governance, compliance, and risk management. In regulated industries, this accountability question becomes even more critical. Organizations need clear policies and processes for reviewing and approving AI-generated code. The reality is that regardless of where the code came from, the development team and the organization team always remains accountable for what they ship. This means having robust verification processes is not optional, it's a business necessity. And that's where Sonar comes in. Before diving into our AI-specific solutions, let me briefly introduce you to Sonar, the company that I work for, which is known for its flagship SonarQube product. SonarQube is an integrated platform for code quality and code security. It does code analysis to build better software faster. Created by developers for developers with open source roots, SonarQube helps development teams in producing secure, reliable, and maintainable software. It is available as a self-managed offering called SonarQube Server and as a SaaS offering called SonarQube Cloud. We support over 30 programming languages and frameworks from Java and JavaScript to Python and PHP, including frameworks like Spring, React, Laravel, and more. It seamlessly integrates into the software development lifecycle with most DevOps platforms like GitHub, GitLab, Azure DevOps, Bitbucket, etc. It also works with continuous integration toolchains like CircleCI, TravisCI, and Jenkins. By automating the detection and remediation of code issues, SonarQube enables developers to write better code faster. There is also a SonarQube IDE extension that can be installed in most IDEs, such as Visual Studio Code, IntelliJ, and Cursor. The SonarQube IDE extension connects with SonarQube server or cloud and helps developers shift left. Now let me introduce you to AI Code Assurance, a key capability of SonarQube server and cloud that helps address some of the challenges that we discussed earlier. AI Code Assurance provides strict verification to catch code quality and code security issues in your AI-generated code before they reach production. A key feature of AI Code Assurance is auto code detection, which automatically identifies code written by AI assistants like GitHub Copilot and applies our AI Code Assurance quality gates to that code, which the AI quality gate has got stringent checks designed for AI-generated code. By implementing AI Code Assurance, organizations can build confidence in their use of AI coding tools. And they get assurance to stakeholders. It gives assurance to stakeholders about the code quality and security and addresses the accountability issues that we discussed earlier. It's about enabling the benefits of AI while mitigating the risks. So how does AI Code Assurance work? The workflow for AI Code Assurance is pretty straightforward but powerful. First, the system auto-detects AI-generated code from GitHub Copilot, or it allows you to tag projects that contain AI-generated code. This ensures that all AI-generated code, a proper scrutiny is applied where needed. Next, it enforces a specialized quality gate, which is called Sonar Way for AI code quality gate. This quality gate has strict criteria for AI-generated code, addressing the unique risks that we discussed earlier. This includes checks for security vulnerabilities, bugs, code smells, and test coverage. When code passes these rigorous checks, it receives the AI Code Assurance Pass status. Finally, an AI Assurance Badge is issued, which can be displayed in repositories or documentation to indicate that the code has been verified and reviewed according to high standards. This process provides transparency and confidence to all stakeholders, from developers to engineering managers to compliance officers and business leaders. While AI Code Assurance helps verify code quality and code security, our AI CodeFix solution takes things a step further by automatically suggesting code fixes for the identified issues. AI CodeFix provides AI-powered code fix suggestions that are contextually aware of your code base and not generic code fixes. With one-click application of fixes, developers can quickly review and resolve issues without leaving their workflow. We offer a choice of LLMs with AI CodeFix that allows organizations to select the LLMs that align with the requirements for performance, privacy, and compliance. And all our solutions, like in all our solutions, AI CodeFix is available in both IDEs for real-time feedback and checking, and in SonarQube Cloud and Server for comprehensive project analysis. So let's look at how all of this works together in the SDLC. Starting with the left-hand side, developers can, in an organization, use their own IDs such as Visual Studio Code, Cursor, or any other ID with AI coding assistants like GitHub Copilot or Codium to develop code. The IDE includes SonarQube for IDE extension, that checks the code being developed on the fly and helps you find and fix issues right away in your local environment. SonarQube for IDE is also configured to connect with SonarQube, server or cloud. This is important as SonarQube for IDE extension will pull code quality standards and quality profiles from SonarQube and apply them in your local IDE. Issues will be raised in the IDE for AI-generated code that does not match with the team or company standards. Additionally, enabling AI code assurance in SonarQube streamlines the process of validating AI-generated code through a structured and comprehensive analysis. This ensures that every piece of code meets the highest standards of quality and security before it moves to production. Developers commit code from the local IDE to a code branch of the application source code repository, such as GitHub. SonarQube server or SonarQube cloud can then be configured to scan and analyze the code repository as a project using the GitHub actions in case of GitHub or any other DevOps platform. Branch analysis and pull request analysis of the code is then performed by SonarQube to help identify code quality and security issues that may need to be addressed. For issues such as bugs, vulnerabilities discovered by SonarQube cloud or server, AI CodeFix can then suggest code fixes. Quality gates in SonarQube server and SonarQube cloud ensure that the code being produced meets the desired criteria for production use. This helps ensure reliability, maintainability, and security of the software being produced. AI coding tools are indeed transforming software development. They offer tremendous benefits, but we need a trust but verify approach when adopting AI for coding in the SDLC. LLM hallucinations are real and can cause code quality and code security issues, making verification essential. Always review AI written code with automated tools. SonarQube with AI code assurance provides the guardrails you need to use AI coding tools confidently and responsibly. By implementing these practices and tools, you can adopt AI to accelerate development while maintaining the quality and security standards of your organization and what customers expect. Here are some valuable resources for you. Our main website is sonarsource.com, and it has information about all our products and solutions that I briefly talked about today. The documentation can be found at docs.sonarsource.com. We also have a blog that offers insights on industry trends and best practices. Our community forum at community.sonarsource.com is a great place to connect with other users to get answers to your questions. You can also connect with us on LinkedIn or X using the handles provided on this slide. Thank you for your time today. I hope this presentation has provided some insights into building reliable software in the age of AI. Thank you.